All right, lesson 8.8, we're going to be looking at the distance formula. And the big idea says that using the Pythagorean theorem, the distance between any points in a plane can be found if you know their coordinates. So we're going to be looking at finding the distance between 2 points. What's this length? If you can't physically measure it with a ruler. Now, any of these lines that go straight with the grid, you can just count boxes, right? This goes from 1 to 8. So that's 7. That distance right there is 7. And we're going to use a formula that finds that for us. And so if we plugged in these coordinates to that formula, we'd get 7. But how do we measure something that's on a diagonal? Now look, this diagonal goes from 1 also to 8. But that's not 7. If you can imagine this laying down, if you just slowly laid it down, it's going to actually be longer than 7. It's not going to sit on this line as you swing this down. If you keep it attached right here and it swings down, it's not 7. So even though it's going from 1 to 8, it's not 7 because it's not straight, it's diagonal. So we need a formula for finding the diagonals, basically. And that formula is the distance formula. And it's going to use a lot of what we've been talking about with square roots and squares. And so we're going to be using 2 points. And so you have your x1 comma y1 for one of your points. And then your other point we're just going to call x2 comma y2. And we've done this before with slope, so that's not new. And so here's the formula. You're going to subtract your x's, so x2 minus x1, and you're going to square that number. Plus, you're going to subtract your y's, y2 minus y1, and you're going to square that number. You're going to add them together, and then you take the square root of that, and that's the distance. Now, nobody just made this up. Where this came from was the Pythagorean theorem. So we're going to kind of show you where this comes from and how it works. So we're going to find the length of A, B in the pictures because we can't just count boxes. If we counted boxes, we'd say it's 7, but clearly it's longer than this line if you laid it down. So 7 is not the correct answer. So we're going to use Pythagorean theorem first, and then we're going to use the distance formula right after that, and they should give us the same answer. Now, you don't always have a triangle, so you can't always use Pythagorean theorem, but in this case, we can do both. So what we're going to do is we're going to do a squared plus b squared equals c squared. Remember that a and b, it doesn't matter which one you choose on either side, but they do need to be the legs. And the hypotenuse across from your 90, that's got to be c. So it's a squared plus b squared equals c squared. All right, and if we count boxes here, 1, 2, 3, 4, 5, 6, again, from 1 to 8, we know that that's 7. And we can measure this one. It's straight up and down, 1, 2, 3. We can't measure the diagonal. All right, so 7 squared is 49, and 3 squared is 9. And if we put those together, that's 58. And so c squared, this measurement squared gives me 58. And if I just want to know what c is the square root of 58. And if we wanted to put that in a calculator to get an approximate decimal, that's fine. Okay, we should test that out and see if I can put that in simplest radical form. So the numbers that would go into it, perfect squares, numbers that have a square root, like 4, so 58 divided by 4, nope, doesn't go in. Like 9, because the square root of 3. 58 divided by 9, nope, doesn't go in. 16, because that's 4 squared. 58 divided by 16, nope. And then 25, I know 25 doesn't go in, and 36. So this is in simplest radical form. So I'm going to leave it like this. If you wanted to approximate with a decimal, you could, but you don't have to. All right, so letter B, we're going to do this now using the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. This will be a formula that you continue to use all the way through high school and all your math classes. So you'll become very accustomed to it. And so what we're going to do now is we're going to measure from this point to this point. So I'm going to, for now, put a key here, x1 comma y1. I'm going to choose this point right here. So it's 1, 2, and my x2 and y2 is going to be my other point, which is 8, 5. So just so you know where I'm pulling these numbers from. All right, so we're going to subtract your x's. So I'm going to do x2 minus x1, so 8 minus 1 squared. Subtract your y's, y2 minus y1, so 5 minus 2. Let's go ahead and simplify in here. 8 minus 1 is 7, so it's 7 squared. 5 minus 2 is 3, so 3 squared. And at this point, you should start to see how this actually is coming from the Pythagorean theorem. You can see we're going to add these together after we square them and take the square root, just like we did here. So this formula was derived from the Pythagorean theorem. Basically does the same thing, except we don't need a triangle for this to happen. All we need is 2 points. We don't need the full triangle. All right, so D equals, we're going to have 49 plus 9, so square root of 58. And again, if we wanted to put that as a decimal, you just plug it in your calculator. Simplest radical form, this is it. Okay, there's no perfect squares that go into 58. All right, so there's the distance formula. You can see where it came from. Here's how to use it. It's pretty straightforward. So if you flip this over, real short notes today, we're just going to try finding the distance now between two given points. So not using a triangle or anything like that, just taking the 2 points. So write down your distance formula. Square root x2 minus x1 squared, y2 minus y1 squared. Now for this one, again, I'm going to go ahead and define my x1 comma y1, and I'm going to call that 4 and 9. And my x2 comma y2, I'm going to call 8 and 6. You don't have to do that every single time. Okay, so x2 minus x1, I'm doing 8 minus 4. And then the question is always going to come up, do I have to go this minus this? Could I do 4 minus 8? And the answer is yes, but just like with slope, the order matters. So if you did 4 minus 8 for your x's, you have to do 9 minus 6 for your y's. I'm doing 8 minus 4. I called this x2 minus x1, so then I have to do 6 minus 9. You have to go the same direction. You have to be consistent. So for my y's here, 6 minus 9 squared. I'm going to start simplifying here. So 8 minus 4 is 4. 6 minus 9 is 3. So 4 squared is 16. 3 squared is 9. I put those together, and that is 25. So the distance between these is the square root of 25, and that is a perfect square on its own. There is a number that if you square it, you get 25. So the square root of 25 is 5, and so the distance between those 2 points is exactly 5 units. All right, so what I'd like you to do is just take 2 seconds, pause the video, and try the last one, and then restart it and see how you did. Okay, so the distance formula, let's get that written down. You should start with that every single time. x2 minus x1 squared plus y2 minus y1 squared. For this one, I'm not going to go ahead and write it out like this. I'm just going to go ahead and plug in. So subtracting my x's, I'm just going to go from left to right here. So I'm going to do negative 6 minus negative 2 squared. Now I know that's going to go plus plus. And I'm going to add my y's being subtracted. Now I went from here to here. So I need to be consistent with the direction. So here was my x's. So here are my y's. Negative 7 minus 0 squared. Let's simplify. Negative 6 minus negative 2 goes plus plus, so it's plus 2. That's negative 4 squared. Now, notice this is in parentheses, so if you go to plug this in your calculator and you do negative 4 squared, if you don't put the parentheses, it's going to give you the answer of negative 16. You need those parentheses. It's negative 4 times negative 4. Otherwise, we've talked about it, the squared is just on the 4, and this is like a negative 1 sitting out front. Okay, this formula is always going to produce positive numbers in here because you can't take the square root of a negative number. So make sure if you're going to plug this in your calculator, if you don't know what this is off the top of your head, you use parentheses. And then here, negative 7 minus 0, that's negative 7 squared. Again, you must use parentheses. If you try this and you're going to call this negative 16, where it's really positive 16, negative 4 times negative 4 is 16. Negative 7 plus negative 7 is positive 49. If you just plug them in your calculator without parentheses and you go with the answer that it gives you of negative 16 and negative 49, and then you try and take a square root of a negative number, it's going to come up as an error, okay? And then you're going to say, what did I do wrong? What you did wrong is you told me that negative 4 squared is negative 16. That's not true. Negative 4 times negative 4 is a positive. Negative 7 times negative 7 is a positive. All right, so we're going to add these together. It's the square root of 65. If it says simplest radical form, this is my answer. Now I should try numbers, my perfect squares, numbers that have a square root like 4 and 9, 16, 25, 36. Those numbers, if I could split them off into square root of 25 times something or square root of 9 times something to get 65, I would want to do that. But 4 is not going in, 9 is not going in, 16 is not going in, 25 is not going in, 36 isn't going in. Think about 6 squared is 36, so 7 squared, 49, that's not going in. So this is in simplest radical form. And if I wanted to go ahead and turn this to a decimal, it just depends on what the directions said. But if I wanted to turn this into a decimal, if it said round your answer to the nearest whatever, nearest 10th, I'd plug it in. Nearest 10th would be 8.1. So this is approximately 8.1.